Hello students, how are you? I hope all you are good. So today we are going to discuss the topic probability. So in this we will discuss what is the probability, different definitions of probability. So fundamental of probability. Let's start. Let's begin with our topic, fundamental of probability. So what is the probability? See the definition. If an experiment is repeated under essential homogeneous and similar conditions, we generally across two types of situations. What are these situations? The result or what is usually known as outcome is unique or certain. Point two, the result is not unique but may be one of the several possible outcomes. So this is the few things which we need to understand for the probability. So what I am trying to say, let me explain what happens when you are doing any experiment like tossing a coin. When you are tossing a coin, so what happens? Either you will get head or you will get tail. What happened? There are two outcomes. First, first outcome, and this is your second outcome. So these are the things which are discussed here. Okay, so this is the result of this outcome one and outcome two, but there is a one thing which we need to understand. Essentially the similar condition must be there. Okay, that means if you are tossing a coin, the coin must be unbiased. That means there is no tampering with any coin. Okay, so it may be possible that the result is unique and it is not necessary that result is unique, but the outcome will be one of these outcome. Okay, so what happen if in any case the process is known, that means the result is known, that is called a deterministic or predictable phenomena. Okay, and sometimes it is not necessary the output is known. So let's see this thing. A phenomena covered in one is known as a deterministic or probable or predictable phenomena. By the deterministic phenomena, we mean one of which the result can be predicted with certainty. Okay. So now the come on the another concept. However, there are a phenomena which do not lead themselves. The deterministic approach is known as a unpredictable or probabilistic phenomena. Such phenomena are frequently observed in business, economic, and social sciences, or even in our day-to-day life. So, what happened? The Actually, the probability is nothing. It is only the measurement of the uncertainty. Okay, so measurement of the uncertainty is called the probability. Okay, where the word arises, that possibility, possible, unpredictable, all these can be called as a probability. For example, there are few examples you have to understand. This example, in a random toss, of a uniform coin, we are not to getting the head or tail. Okay, a manufacturer can not ascertain the future demand of the product with certainty. What it means, in first coin, you cannot say surely that we are going to get head or tail. In second case, no one, the producer can say that, producer or manufacturer case say that what is the demand in future. Like for example, if in certain year the demand of a iPhone is assume that 1 lakh quantity, but it is not necessary that in coming year the demand will be the same. And similarly, when we are talking about the sale, this is another example, so we go through that example. Okay, so now This is the few definitions you have to remember. This is the example 1, example 2, example 3. Okay. For example, there is a high chance of getting my job next time. This is not, again, not certain. High chance. That means possibility is there, but it is not a certain. This year, the demand of product is likely to exceed that the last year. That means now the demand is going to increase. This is also possibility. This is not 100% sure. The odds are 3:2 in favor of getting the contract applied for. What happen if you apply for any contract? It is not 100% that means out of 3 by 2, this is a chance that you will get the project. So what happened? The above all sentences cover the words probable, possible, high chance, likely, and odds. These are all represent the uncertainty. So this uncertainty is called a probability. Okay. Now come on the definition. A numerical measure of uncertainty is provided very important branch of mathematics called the probability. Okay. So what happened? Broadly, there are three possible states of the expectations: certainty, impossible, probability. The probability theory describes certainly one by one or impossible by zero, and the various grade of uncertainty by coefficients ranging between 0 to 1. What here we are trying to say? We are saying that there is one thing that certainly you will get head or tail in while you are tossing the coin. That means there is a certain result, either you will get head or tail. It is next to impossible that you will get both head and tail in the tossing of the coin. So this is impossible. And probability, that means you can get one of this. That's why the probability is always any event. If event is, the probability is always lies between 0 to 1. So what happened? Only you have to remember this underlying part of the definition. And according to Yali Chow, the probability is a science of decision making with calculated risk in face of uncertainty. Again, the word uncertainty is there. So decision making probability can also help you in a decision making. So now come on the official definition of probability. What happen if probability is a concept which numerically measures the degree of uncertainty and therefore the uncertainty of the occurrence of events. For example, if an event E happens in M ways and fails in N ways, then what happen? Happening is represented by M and fail represented by N. So what happen? For a event, you have, so total number of event is M plus N and our favorable event is M. So probability of E of event E is equal to the number of favorable cases upon total number of mutually exclusive and equally likely cases. We will discuss these two terms in next topic. Okay. So the probability is given by M upon N. So it is clearly the ratio of favorable outcome upon total number of outcome. And while you are going to find the probability of failing, so when you are discuss about the failing, fail means N and total number of possible cases are M plus N. So this is the probability of failing. Now come on the next part. if the probability of happening is P, another instead of considering a M and N, we are considering P. If the probability of happening P and not happening Q, okay, then always the probability, if you put the value of P and Q, the value of P, that means happening, is given by M upon M plus N in our previous year, and not happening is given by N. If we summarize these two, take the LCM and solve it, it gives you a P plus 1. That means the probability of happening and plus probability of not happening is always given by 1. So if we are representing the probability of happening by A and probability of not happening, that means not happening, the complement of happening is always given by not happening, and that is A bar. So that means the sum of probability of A plus probability of A bar is equal to 1. So if A is the event, then A bar is the its complement event. Okay. Now classic definition. So this is another classical definition. It is another definition. Go through that one. We already discussed this thing, that probability is always a positive output, positive number, but it is not a negative number. So you have to understand this thing. Now there are few words which you need to understand in the probability. So these definitions are very critical definitions in the discussion of probability. Random experiment. What is the random experiment? First we need to understand what happened if you are tossing any coin, that it is not necessary that head is onward or tail is upward. Okay, you can toss in any way to any egg. So see here, if in each trial of experiment conducted under identical condition, the condition must be identical, the outcome is not unique but may be any one of the possible outcomes, then such experiment is called a random experiment. What here we are trying to say, that means when you are tossing coin, there is no certainty of getting the head and tail. It may be you get head or you get tail, but it is possible, it sometimes it is also possible that each and every time you are getting head. So this is the example. So what happened, the tossing process of coin, whatever the output, either it is head, either it is tail, or continuously you are getting head, or continuously you are getting tail, but all these are called a random experiment because there is no such rules and regulation to toss the coin. Only one condition is that that coin must be fair. Another example, out of 52 cards of any pack of cards, there are a spade, heart, diamond, and club. Each suite consists of 13 cards, of which 9 cards are numbered. Actually, what we are trying to discuss here, many of the students are not familiar with the cards. So there are four type of cards. One is spade, another is called heart, diamond, and club. And each of these four, that means the four, if you write spade, heart, diamond, and club C. This has a 13 card, 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 and if we sum it, total number of cards in a deck or in a pack are 52. And further, the definition of this card is given that 9 out of 13, 9 cards are numbered card. This T is not there. That means 2 to 10 numbers. That means if we start writing 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you count, you get total 9 cards. And after then, there are 4 more cards. 9 plus 4 gives you a 13. So what happened? You have a one ace, that's called Ikka, king, and then you called queen and jack. Okay. So all the spade, all, let me highlight it, all the spade and club are black colored card. On the other hand, heart and diamond are red color card. So this is called your card cards classification. Now come on another heading, outcome. So what happened? What is the outcome? The result of the random experiment will be called an outcome. It is also an important trial and event. Any particular performance of a random experiment is called trial and outcome, or combination of outcome and outcomes are termed as event. What happens if you are tossing the coin? Either we will get head or we will get tail. So what happened? Head is a one event and tail is the another event, or you can say the combination of these is also called the event. Okay, so go through all this example. There's another definition called simple and compound event. Event is called simple if it corresponds to the single outcome of the experiment. Otherwise, it is known as a compound or composite event. Let's see and I try to understand what is as as a tossing of a single die. The event of getting 6 is a simple event. Okay, 6, if you are getting 6, that is a simple event. But the event of getting even number is called a composite event. Again, see, you know that either you get 1 or we get 2 or we get 3 or we get 4 or we get 5. Okay, beta, or we get 6. Anything you can get on the die throw. So if you get 1, that is also simple event. If you get, this is also simple. If you get 3, this is also. So each of these 6 cases are simple cases, because at a moment you can get only one output. But what happened when we are talking about the even number? That means it may be possible. Just give me 1 minute. It may be possible that you can get 2, you get 4, you get 6. So there is a 3 numbers. So what happened? This is a composite or compound event, because you can event can be defined any by 2, 4 and 6. But 6 is a simple event. So remember, when the output are multiple outputs give your out answer, that is a complicated or complex or composite or compound event. But if the output is a single, then it is called a simple event. Now the exhaustive event or cases. What is the exhaustive event or cases? See, the total number of possible outcomes of an experiment known as the exhaustive event or cases. जितने भी आउटकम आपके आ रहे हैं किसी एक्सपेरिमेंट करने के बाद, आपने टॉस किया, यू आर गेटिंग टू थिंग्स, हेड एंड टेल, दैट इज योर exhaustive events. Okay, so total count of event is called the exhaustive events or cases. Example is given there. Now come on the favorable event. What is the favorable event or cases? Favorable event means the output which we are looking for. That is called, if we get that is called a favorable event or favorable outcome. For example, if we are tossing 2 dice, remember die is the single word, similar, and dice is the plural. So what happens if we throwing 2 dice? So getting of 5, if we are looking for the 5 output of 5, so what happened? 1 plus 4 is 5, 4 plus 1 is also 5, 2 plus 3 is 5, and this also 5. That means on first first die we will get 1, second die we will get 4. So this is a combination of first and second die. So what happened? There are 4 favorable cases for us getting 5. So this favorable event. Equally likely event. This is also very important heading which we need to understand. Outcome of trial are said to be equally likely if taking into consideration all the relevant evidence. There is no reason to expect one in performance to the other. What they are trying to say, this definition try to say, when we are performing any random experiment, the output one will not expect the output of another. ओके, सिंपल सा मैंने कहने का मतलब है कि अगर एक आउटपुट टेल आ रहा है तो टेल विल नॉट अफेक्ट द हेड कमिंग प्रोबेबिलिटी ऑफ कमिंग ऑफ हेड. सो रिमेंबर दिस थिंग, देयर इज नो रीजन टू एक्सपेक्ट वन इन परफॉर्मेंस टू द अदर. एक के काम में दूसरा कोई आपका, तो दैट मीन्स सेम चांस है हेड आने का और सेम चांस है टेल आने का. दिस इज कॉल्ड इक्वली लाइकली इवेंट. फॉर एग्जाम्पल, if I want to select a student in a class, if there is no condition, that means I have to select the student whose CGPA is greater than 9, then I can choose any student randomly. But if condition is there, so we have to go. So what happen when unbiasing unconditional things are there, then all the students have equal chance to select for any purpose. Okay, so go through all these two examples are there. Now come on the another topic, independent events. Two events are independent when actually happening of one does not influence in any way the probability of happening of the other. Okay, दो इवेंट्स तब इंडिपेंडेंट होते हैं जब एक इवेंट होने पर दूसरा उसको किसी प्रकार से इन्फ्लुएंस ना करे. फॉर एग्जाम्पल, व्हेन अ डाइस इज थ्रोन ट्वाइस, द रिजल्ट ऑफ फर्स्ट थ्रो डज नॉट अफेक्ट द सेकेंड. जब हमने एक डाइस को फेंका तो क्या हुआ, जो पहले, फॉर एग्जाम्पल, इफ इन फर्स्ट थ्रो वी गेट 4, तो 4 विल नॉट अफेक्ट बाय द थ्रो ऑफ सेकेंड टाइम. ओके, आप हो सकता है सेकेंड टाइम भी 4 आ जाए, एंड इट मे बी पॉसिबल सेकेंड टाइम इट गिव्स यू अ 6, एनी नंबर ऑफ देम. ओके, 6, 4, 2. द इवेंट ऑफ गेटिंग हेड इन फर्स्ट कॉइन and event of getting tail in the second coin in a simultaneous throw does not affect each other. हमने दो सिक्के, दो कॉइन टॉस किए, पहले में हेड आ जाए दूसरे में टेल आ जाए, तो पहले में हेड आने से दूसरे में टेल आने का कोई रिलेशन नहीं है. तो दीज आर कंप्लीटली इंडिपेंडेंट इवेंट्स. एंड व्हाट हैपन, देयर इज अनदर डेफिनेशन कॉल्ड डिपेंडेंट event. What is the dependent event? If the occurrence of one event influence the occurrence of other, then second event is said to be dependent event of the first. Okay, for example, if a person draw a card from the full pack and does not replace it, the result of the draw made afterward will depend on the first draw. What I am trying to say, just see, understand. There are 52 cards are there. So what happens if we select one card and that is, for example, it is a jack. हमें एक जैक मिल गया और assume this is the jack of club. Okay, jack of club. So what happened? Now how many cards we left? Only 51. So what happened? अब अगर आपको नेक्स्ट टाइम क्लब का जैक चाहिए, तो क्योंकि क्लब का जैक तो ऑलरेडी बाहर आ चुका है और इस कार्ड का हमने कोई रिप्लेसमेंट नहीं दिया है, तो क्या हो गया, सेकेंड टाइम जैक आना डिपेंडेंट हो गया किसके ऊपर, जो हमने फर्स्ट एक्सपेरिमेंट किया था, क्योंकि जैक तो अब इस कार्ड में है ही नहीं है, तो अब जैक आने की प्रोबेबिलिटी 0 हो जाएगी। तो इसीलिए जब आपने एक कार्ड ड्रॉ कर लिया और आपने उसको रिप्लेस नहीं किया, तो जो कार्ड आ चुका है उसकी प्रोबेबिलिटी आने की 0, तो ये आउटपुट डिपेंडेंट हो गया किसके ऊपर, फर्स्ट एक्सपेरिमेंट के ऊपर। म्यूचुअली एक्सक्लूसिव इवेंट, व्हाट इज द म्यूचुअली एक्सक्लूसिव इवेंट? Mutually exclusive events means events are said to be mutually exclusive or incompatible if the happening of any one of them preclude the happening of other of all other. That is, if no two or more of them can happen simultaneously in the same trial. What they are trying to say, mutually exclusive means if one, अगर कोई एक इवेंट हो गई, if one event already occurred, okay, so this does not include the happening of other while we are simultaneously performing any trial or random experiment. अदर वर्ड्स में, इसको सिंपल वर्ड्स में समझ लेते हैं। इन अदर वर्ड्स, टू इवेंट्स आर नोन एज म्यूचुअली एक्सक्लूसिव व्हेन अकरेंस ऑफ वन ऑफ देम एक्सक्लूड द अकरेंस ऑफ अदर। फॉर एग्जाम्पल, टॉसिंग अ कॉइन, आइदर वी गेट हेड और टेल बट नॉट बोथ। ओके, तो क्या होता है, एक के अकरेंस को होने पर अकरेंस ऑफ वन ऑफ देम एक्सक्लूड द अकरेंस ऑफ अदर। एक अगर इवेंट हो रही होगी तो दूसरी नहीं होती है। अगर एक टाइम पे आप क्लास में हैं तो उसी टाइम पे आप क्या हो सकता है, अपने घर पे नहीं हो सकते हैं। सो रिमेंबर दिस थिंग। ओके, कॉम्प्लीमेंट्री इवेंट, व्हाट इज द कॉम्प्लीमेंट्री इवेंट? लेट्स सी द कॉम्प्लीमेंट्री इवेंट। कॉम्प्लीमेंट्री इवेंट को हम आपको ऐसे समझाते हैं दूसरे टर्म्स में। यहाँ पर जो लिखा है, व्हाट इज रिटन हियर, यू जस्ट रीड इट। If A is the event of any sample space, that means A is a subset of S, and A is the complement of A is A bar, and it is also a subset of S. तो कॉम्प्लीमेंट क्या, अगर ए किसी चीज की हैपनिंग की प्रोबेबिलिटी थी, इवेंट थी, तो ए बार क्या है, ऑल नॉन हैपनिंग की प्रोबेबिलिटी है। अगर किसी बच्चे को पास होने को हम ए से, अगर हम किसी बच्चे को पास होने को पी से रिप्रेजेंट करते तो उसे फेल होने को हम फेल ना लिख के पी बार, दैट मीन्स अपोजिट ऑफ पास इज कॉल्ड इज दैट इज रिप्रेजेंटेड बाय बार। So, and what happens, sometime A bar is also represented complement of A, and it is also represented by A dash. So if we are writing the probability of happening of event A by A, then probability of not happening of A is equal to A bar, and we already discussed that. And what happened, there is nothing common in between these two happening, and that means the intersection of these two is always equal to phi. So see, this is the definition. Okay, so uh, so remember this thing. Okay, so just a minute, let me take one minute. So remember this thing, and probability of the sum of the probability, this probability of happening and not happening is always equal to 1. Okay, so remember this thing. And now come on another topic. So this is the summary of the probability. The conclusion of all the discussion is the probability of an event is the ratio we already discussed. Since 0 and m क्या है? M is the where m is the favorable cases and n is the exhaustive number of cases. Exhaustive number of cases means all cases. N represent all cases, that means total number, and M represents your favorable cases. Okay, so remember this thing. So the probability of impossible event is zero. That means if any impossible event is there, then it is zero. Probability of 100% confirmation is 1. So probability always lies between 0 to 1. And the probability of happening, probability of happening, non-happening, okay, is given by 1. Sum of these is equal to 1. Okay. But remember A bar and A don't have any common case. Okay. So there is another heading we have to remember, odd in favor. That means odd in favor means the ratio, and ratio is m upon m, and odd against its event is m upon n. Okay, so also remember this. This is in m is in your favor, and the total number is given by m plus n. Okay, this is total number. This is, that means success, and this is n represent fail. That means not happening, and this is past, that means happening. So this is the ratio. Now the conditional probability is there. So what is the conditional probability? The conditional probability is that means one event is A and another event is B. So what happens if A dependent on the happening of the event B, then that is called the conditional probability, and this is denoted by P of B, and it is read as the conditional probability of event A given that event B already happened. B के होने के बाद ही हमारी event A अगर होती है तो that means this is a dependent on one. So what happened? It is written by P of B. Okay, so this is the important definitions of the probability. Now we are going to discuss some small and simple question based on the probability, and after then we will discuss the complicated questions and other definitions of the probability. So read this file very carefully, you will get all your outputs. Okay, so now we are going to discuss few problems here. Problem number 1, and we have to see its solution. If odd are 2 to 3 in favor is equal to 2 is to 3. Okay, that is, this is the probability of happening of, that means in favor A. Then the probability of occurrence, find the probability of occurrence of A, also find the probability. So the probability of occurrence of A, that is probability of A equals to, in favor is 2 and total number is 2 plus 3 because this is a ratio, so that is 2 upon 5. Since we know that, what we know that probability of happening plus probability of not happening is equal to 1. This implies that probability of not happening, that means in not favor, is equal to 1 minus 2 upon 5. This implies that probability of P is equal to 5 minus 2 upon 5 is equal to 3 by 5. So this implies that probability of A bar is equal to 3 by 5. So these are the answers. This is your first answer, second answer, and this is your first answer. and we can also calculate probability of A bar by the ratio 2 upon 3. So this is in favor. So what is the ratio in against? That is means 3. 2 is in favor and 3 is against. So the probability of A equal to 3 upon 2 plus 3. So probability of A bar is equal to 3 upon 5. This is the also one method in which we can find the probability of this segment. Now come on another question. So solution. Find the probability of an event A if odd against it are 3 ratio 5, 3 each to 5. So against, this is against, so the odds against is given by 3 is to 5. So probability of happening, so the probability of happening in favor we have to calculate. So probability of A bar is equal to, what is the probability? That means 3 upon 3 plus 5. This is equal to 3 upon 8. So this implies that probability of not happening is equal to 3 upon 8. And since we know that probability of happening plus probability of not happening equal to 1, this implies that probability of happening equal to 1 minus probability of against of odd, you can say it. The probability of favor of this ratio is equal to 3 upon 8 is equal to 8 minus 3 upon 5. This implies that probability of A is equal to 5 upon 8 is the answer. So what we will get? The probability of event A is this one. Okay. Now come on the question number 3. There 3 of the 6 vertices of a regular hexagon are shown at random. Find the probability that the triangle with 3 vertices is equilateral. So first we have to understand the question, then we will solve its solution. What is the question? First we will draw the hexagon. One point is this one. So draw the point, draw the line, then draw one vertical line, then this and this. Just merge it. If we give it vertex 1, it is vertex 2, it is vertex 3, it is vertex 4, it is vertex 5, it is vertex 6. 3 of the 6 vertex of a regular hexagon chosen at random. 3 सेलेक्ट करते हैं तो आप चेक करो, आप अगर 1 सी यू नो दैट ऑल दीज एंगल्स, ये सारे एंगल्स कितने होंगे? all these angles are of 120 degree each. 120 degree. So if we select 1, 2 and 3, so what happen, we join this line and you see this angle is 120, and in equilateral triangle, equilateral triangle, equilateral triangle, all angles must have a 60 degree. Okay, so 100% all the consecutive vertex cannot be chosen. So let's select to another vertices. So let me complete this. Okay. So what happen if we select 1, 3 and 5, all odd? So I am selecting 1, 3 and 5, all odd vertices. Odd vertices. So what odd vertices, when you select this, draw the diagram, combine it. This will draw like that one. This will draw like that one. And this. So what happen? You are getting a triangle, and each angle of this triangle will be 60 degree. So one possible pair, one possible triplet is this one, and another possible triplet, all even number, 2, 4, 6. See, I am taking a red pen and then draw. If we taken, then what happen? Draw this, connected by 4. So what happened? Another triangle can be drawn by red. Okay. So there are two combination of vertices which are in our favor. How many? So favorable combination, favorable combinations equals to 2. अब हमने फेवरेबल कॉम्बिनेशन निकाल लिया. अब what we need total number of combination, total number of combination to select 3 vertices equal to 6C3. So 6C3 equal to factorial 6 upon factorial 3 upon factorial 3. Since we know that NCR is equal to factorial n upon factorial n minus r into factorial r. So this gives you a 6 into 5 into 4 into 3 into 2 into 1 upon 3 into 2 into 1, 3 into 2 into 1. So what happened? This will cancel with this one. This 6 will cancel by 6. So we have 20. Therefore, the probability of the probability of event A is equal to how many favorable cases are 2 and total 20. So that gives you a 1 by 10. So this implies that probability of event A, that means to select a equilateral triangle, is 1 by 10 is the answer. Now come on another part, that is our question number 4. Solution. what is the chance that a leap year selected at random contain 53 Sundays? So how many days? Days number of days in leap year is equal to 360. Okay, so we know that we know that in a week how many days? In a week, 7 days. So total number of weeks in year is equal to 52 into 7 into 7, sorry, is not into 7, is equal to 52. So total number of days equals to 52 into 7. This gives you a 364. So 2 days are left. So what happened? Only 2 days are left, and the total 360 are used in a 52 weeks. So out of these two, we have to find there are 7 days. How many days? 7 days. Start from Monday to Saturday. Monday to Saturday. 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 तो व्हाट हैपन? अब देखो हमारे पास, क्योंकि टोटल मैं इधर थोड़ा सा आपको एक्सप्लेन कर रहा हूँ, ये आपके लिए बहुत ज़रूरी चीज़ है, दिस इज इम्पोर्टेंट थिंग। 360 डेज थे, इसमें से 364 यूज्ड ऐसा, इसमें से यूज्ड ये डेज हैं, ये यूज्ड हो गए हैं। कैसे यूज्ड हो गए हैं? 52 वीक्स में। तो ओनली 2 days लेफ्ट। हाउ मेनी? 2 days लेफ्ट। और इस 2 days में हमें सेलेक्ट करना है एक संडे, 1 संडे विच इज फेवरेबल। तो हाउ मेनी डेज आर देयर? ओनली 2 favorable cases are there. 2 favorable cases are there. That is either Saturday, Sunday, सैटरडे और संडे हो, और दूसरी पॉसिबिलिटी क्या हो सकती है? संडे, मंडे हो। क्योंकि इसके अलावा जो कॉम्बिनेशंस बनेंगे वो कॉम्बिनेशंस बन सकते हैं क्या? नेक्स्ट पेज में वो कॉम्बिनेशंस बन सकते हैं वो कॉम्बिनेशंस बन सकते हैं मंडे कॉमा ट्यूसडे, ट्यूसडे कॉमा वेनेसडे, वेनेसडे कॉमा थर्सडे, थर्सडे कॉमा फ्राइडे, फ्राइडे कॉमा सैटरडे, सैटरडे कॉमा संडे, संडे कॉमा मंडे। तो हमें क्या चाहिए, जो बचे हुए 2 दिन थे उसमें से हमें एक संडे चाहिए। तो टोटल 1 2 3 4 5 6 7। तो आउट ऑफ 7 केसेस, तो व्हाट इज द एग्जॉस्टिव इवेंट? आउट ऑफ 7 केसेस, टोटल possible cases are 7 and favorable cases are 2. So probability of, what is the question? So the probability or chance of getting 53 Sunday, the probability of event A is equal to 2/7. This is your answer. Now come on and the question. This is question number 6. Solution, and then we will read the question. Suppose we have the following information about distribution of marks of 1,000 students in college. Okay, total number of students are, total number of students are 1,000. So 1,000. So total number of students are 1,000. Now come on the, now now a student is selected at random. Then let us find the probability that his marks are, point number 1, under 30. Case number 1 is first, marks are under 30. So see, under 30 means this is the period where all the marks less than 30 marks are these one. So how many students who have less than 30 marks? 40 plus 50 plus 150, that gives you a 240 marks are under 30. The total number of students for the condition is 240. So probability of event E is equal to, what is the value? 240 upon 1000. So 0 will cancel and this gives you a 0.24. Okay, this is the probability. Now case number 2. Case number 2. Case number 2. What is the case number 2? Above 50. What? How many students who get the above 50? See, this is the range which lies between 0 to 49, and this segment has the, what is the segment has a 50 to 70. That means above 50. So total strength is 100 plus 30 is equal to 130. Total number of students having marks above 50 is equal to 130. So now the probability P E is equal to P E E कह लीजिए, आप इसको कुछ और नाम दे दीजिए, आप इसको ई ना करके दूसरी इवेंट है, से इट पी बी, तो पी बी इज इक्वल टू 130 अपॉन 1000, so is equal to 0.13. Now the last case, between 20 to 50, of all these things, 20 to 50. So now select the range 20 to 50. So 20 will begin from here, 20 to 50, this range, and we will select this range. So this is 20 to 50. So 150 plus this gives you a 0 plus 0 plus 0, 0, 3 plus 0, 4 plus 5, 8, 2 plus 4, 7, 80. So write it. Case 3. Case number 3. Number of students having marks between 20 to 50 are 780. So probability of marks between 20 to 50, probability of C is equal to 780 upon 1000 total, so is equal to 0.78. So the probability of students getting marks in between 20 to 50 is the answer. Now see another question, and in this question number 6, what the question is asking, see it carefully and then we will discuss the solution. So what happened in this table, there are two type of data is given. One is the in the following by rate vacancy table, we are given the distribution of the marks of 250 students in economics and statistics. This table, this complete thing represents the marks of the statistics, and this represents the marks of the economics. So we have to find the probability of the students as per the given condition. So case number one, solution. Case number one, case first. What the case first? Find the probability of the student whose economics marks in group 20 and 30. 20 or 30, this is the range. Economics marks with and secure more than 40 marks in statistics. More than 40 marks in statistics, that means this column. So we have to find the intersection point of these two columns. So what happened this 10? What happened? 10 satisfy both the condition. That means this is the data of students. This column, see this column. This is the data of the students who secure or score the marks in economics between 20 to 30 and above 40 in this column. Okay, so you have to choose the intersection above. This is also counted, but the intersection point one is the 10. So now so probability of A is equal to 10 upon 250 is equal to 0.040. In details, let's discuss the things in detail. So what happened? The students having economics marks between 20 to 30 and marks in statistics greater than greater than greater than 40 equals 10 plus 0 is equal to 10. Then favorable number equals to 10 and total number of students are 250. So probability of A is equal to 10 upon 250 is equal to 0.040. Okay, in this way we can find the answer. Case number 2. Case number 2. What this case number 2 is telling? Just go and read there. Case number 2. Select the selected students Marks in statistics are in group 50 to 40. Statistics, this is your, just see. The statistics is this one. And marks in group 40 to 50. And their score in economics is greater than 40. This is greater than 40. This column is also greater than 40 and this also in 40. In 40. So come and see this, see this. So draw a vertical line. So what happened? We have to select, these two numbers. So as per condition, total number of students are 20 plus 30, 20 plus 10, 20 plus 10 equals to 30, who satisfies the condition, and total students equal to 250. So probability of B equal to favorable number of students upon total number of students. So probability of condition B is equal to 30 upon 250. So is equal to 3 upon 25 is equal to 0.120. So probability of B is equal to 0.120. This is our final answer. So this is the discussion of the simple questions of probability. In our next lecture, we will discuss the detailed topic or few high level thinking question. Bye bye. Have a good day.